day, guys. Here we are having a Mola WhatsApp. So I've created some chat for this project I'm having. So this chat is going to help some learners, some kids, so that while studying or while referring from topic called Newton's law. So we're going to discuss this topic called Newton's law. So Newton, it was discovered by Isaac Newton while sitting under the tree of apples. So some apple just fell off. So he wanted to discover why the apple just fell off from the tree. So he discovered that the apple was driven off from the tree by gravitational force. So he wanted to discover what is the gravitational force and what happens to the real world. So he did this topic called Newton's law. So now we are going to discuss first law, second law, third law, static frictional force, and frictional force. We're not going to talk about universal gravitational force and some other of Newton's law. So here we are having some of the some note that I've created. So first of thing, we have first law. What is the first law? First law is an object will not change its motion unless acted on by unbalanced force. So that means that first law means that simply means that while any desk or something some object while being put on some of desk or table or somewhere. So it means that while that desk will not move unless it is acted by an unbalanced force. So unbalanced force means that a learner or some kid can move that table somewhere else or somewhere he wanted to put that table. So it means that first law that it is the definition of what of first law. So let's go to second law. Second law means if the resultant force or net force act on an object, it will cause the object to accelerate in the direction of the net force. So simply means that while driving a car has an engine. So means an engine is a what is an applied force. So and the acceleration of the boat is directly proportional to the net force acting on the body and inversely proportional to the mass of the body. So the last line means that while sitting in a car, while having some cement or something. So, while having those cement or something, while the mass increases, the speed will decrease. So that means that while the mass increases, speed decreases. While the mass decreases, speed increases. So that means they are inversely proportional. Others decrease, others increases. So, third law: for every action, there is an equal and opposite reaction. And if object A acts or a force on object B, then the object B will exert an opposite equal force on object A. So that means that when I'm compressing or I'm pushing this wall, then this wall also pushes the same force I applied on the wall. So it simply means that while I exert some force on something, that object will exert the same force on me, but in opposite direction. So we are having a frictional force. What is a frictional force? A force that opposes the motion of an object. So frictional force simply means that while an object is moving on a rough surface, it means that on a rough surface that object is trying to move, but there is something that grabs the object. So it opposes the motion. It makes the object to be slower or somehow. So we are having a static frictional force, the force that opposes the initiation of motion between the surfaces that are in contact and rest related to each other. So static force acts on an object while it at rest, while it's not moving. So if while we mean that something is at rest, then we mean that velocity is zero, then acceleration is zero. So that object is not moving. So we have the two identical objects. So now we are going to explain two identical objects. So I have 5 kg on an horizontal surface, and also I'm having a 5 kg object on an inclined slope of 30 degrees. So here we are having an applied force. So the applied force that is being applied on object is moving to right. So and also on the inclined slope is also moving to the right. So I like to encourage some learners that while dealing with the Newton's law, take the direction that is being applied. Don't take another direction. When the object going to right, take the right position, take the positive as a right direction. While the object is moving to the left, take left as positive. Don't take another way because we're going to have some different answers. So we're going to cause some conflict within the class. So here we're having free body diagrams for the two objects. So here we are having applied force, normal force, gravitational force. So normal force and gravitational force, they are equal because of what? Gravitational, because of the object is not moving. And also we are having a static frictional force. As we elaborated, the static frictional force acts on an object while it at rest. So the object on horizontal surface is not moving. So we are having static frictional force. Whereas on inclined surface we are having a frictional force. So frictional force, we have it while the object is moving. While it's not moving, we're not having a frictional force. But while it at rest, we have the static frictional force. So we have a force diagram. A force diagram is also elaborated as a triangle, and then we have applied force, static frictional force, gravitational force, normal force. Here we are having a static frictional force because I'm trying to elaborate that force diagram on a object on a diagram one, whereas the 5 kg is on the horizontal surface. And here we are having some of the freeboard diagrams. Some of us we are not writing freeboard diagrams as usual. So I'm having a freeboard diagram that is different from the first one. So this one, it does not have component. So this one has component. So as you can see, I have normal force, I have FG perpendicular. So I've created FG perpendicular because of what? Because of the 5 kg, it is on the inclined slope. So it is on horizontal. It's not on any horizontal slope. It is on an inclined slope. So we are having FG perpendicular, we are having FG parallel. So if we can take perpendicular and FG parallel, is going to be equal to normal force. So that's why I'm having a short FG perpendicular and a short FG parallel. So that means if we add these two components, we're going to have a normal force. And then here we are having a frictional force. Frictional force we're having it because the object is on its movement. It's on at rest. So we are having an applied force. And here we are going to have a Froebel diagram on an object that is being pulled up, not on the surface. So we are having an object that is being pulled up from the surface. So it's being pulled up by 15 degrees angle. So here we're going to have an different Froebel diagram. So here we're going to have normal force and F applied. So I've drawn this Froebel diagram with some component. So we are having normal force and applied force, and we are having F at x. So this F at x elaborate the angle between the angle between the rope that is been pulling the object. So here we're having F at x, Fk, F normal, and applied force, and we are also having Fg. Fg is called gravitational force, that is 9.8. So that's all we can say for now. So here we're going to explain we are going to explain some formula. So we have F net is equals to mass times acceleration. So F net means the summation of all forces. So when I'm having this force, let's say I'm having a discussion that they say calculate frictional force. So while I'm going to calculate the frictional force, I'm going to use horizontal I'm going to use horizontal forces. So I'm having static frictional force and applied force. So I'm going to use frictional force and applied force. So I'm going to say F net is equals to mass times acceleration. So I'm going to have Fs plus F is equals to mass times acceleration. Where I see M, I will include mass. Mass means 5 kg that I'm having with this object. So acceleration is going to be given, or they're going to say that we are on initially we are at rest. So while we are at rest, we're going to put 0. So we are having Fs max. Fs max is that means static frictional force. So we're going to say static Fs max is equals to coefficient of static times normal force. So static of frictional force we're going to be given or somehow. So it means that static frictional force multiplied by normal force. Normal force is equals to Fg. So it's going to be Fn is equals to Fg. That means you're going to say M times G. M times G, that means 5 times 9.8. So here we have, and also they could say calculate the frictional force. Frictional force is also going to be static of frictional force times normal force. It's going to be mass times acceleration times static frictional force. And also we have in this diagram, let's go back to this Freiburg diagram. whereas we're going to have Fn plus F plus Fg. So we are going to add all components. So that means Fn plus F is equals to Fg. Well, they are together. So that's all we can say for today. I thank you. Oh, and I want to say love.